So good afternoon, everyone. Thank you all so much for being so patient with me this week and last week as I've been conducting TAD testing. We're on our final day today, but I didn't want us to miss out on another day of class. So I decided that we will record today's lesson and watch it live in class. You'll also have access to this to go back and watch it as needed. So I hope that you all will still actively participate because I'm going to be active in the chat as you all are working through this. But we are going to start off with our bell ringer today. And our bell ringer does ask, in what ways are heat transferred? So take a few moments. I'm going to pause to listen here, but go ahead and in the chat put your answers to our bell ringer question. In what ways are heat transferred? So hopefully by now you've answered that bell ringer question in the chat. And this should be a review of some concepts that we've learned through sixth grade and seventh grade. As this is not our first time talking about the transfer of heat, but we are going to explore this in our lesson today. And hopefully, a lot of this rings a bell as a review as we get prepared for our mini lesson on today. So, as we begin to take a look at our agenda today, we're going to briefly go through our procedures and announcements. We are then going to review our heat transfer mini lesson before taking some time to look in Canvas at our assignment. And just as a reminder, you all, please be sure that when you're joining class, you're joining with your cameras on. It's very important that you all have your cameras on. Even if you put them in privacy mode, we want to be sure that we always have our cameras on during class. Also, if you're experiencing device issues, so any issues that you're encountering with your device, please be sure you're reaching out to our help desk for support so that we can, if we need to get those devices swapped out, we can. So, a few announcements this week. First up is that on Friday, we are going to have Fade First Friday. So, we are going to operate on a modified schedule. So, I am going to see you all at 12:35 on Friday. We'll have an abbreviated class from 12:35 to 1:20, so about 10 minutes off our class time. But we are going to observe this modified schedule so that we can be prepared for our Fade First Friday activity at the end of the day. Also important to note here is that on Friday, our 9-week grading period ends. So all grades will be due by Friday for progress reports and flex attendance. So this is your final chance to go ahead and get those assignments turned in. Get your grades up to an 85% or higher so that you can be eligible for flex attendance if that's something that you want. But we also want to be sure that we do have decent progress reports that we can send home to our parents so they may see. Looking at our assignments and due dates, this week we do have 2 assignments to complete. And we're just going to call this week a lab week. So we have our 02.02 heat transfer lab due on Wednesday, and then our 02.03 potential energy and kinetic energy lab due Friday. Both of these are very fairly easy labs to complete, not very detail oriented. You're going to be using a simulation as we don't have equipment at all of our houses to complete these labs. So we are going to be using a simulation, and we'll take a look at what all that entails a little later. So as we are looking at our energy unit, our standard is S8P2D, where we plan to carry out investigations on the effects of heat transfer on molecular motion as it relates to the collision of atoms with conduction through space, radiation, or in currents in a liquid or gas, which is convection. Our learning target is I can explain the transfer of heat. So let's take a look at some of this today with thermal energy. So a lot of this is going to be a review. We've been talking about this for the past 2 years. So thermal energy is just the sum of kinetic and potential energy of the particles in an object. Thermal energy will increase as mass increases, It also increases as temperature increases. Temperature is a measure of the average kinetic energy of particles in an object. So the higher the temperature, the faster the particles are going to be moving. So, how do you know if someone has been sitting in your chair? Well, to answer that question, you probably go back to your chair and feel that it's a little warm. Thermal energy always flows from higher temperatures of objects to lower temperature objects. So, heat is the transfer of energy from one object to another. It is measured in joules. So, when looking at the transfer of thermal energy, something that you all may not be aware of is there's no such thing as cold. And you may be asking yourself, what do you mean by there's no such thing as cold? I know when something is hot and when something is cold. Well, actually, when you feel cold, you're simply feeling the absence of heat. So let's take a look at this example. What happens when you hold a cold drink and your hand starts to feel cold? Well, what actually happens is heat leaves the higher temperature object, which is your hand, and transfers to the lower temperature object, which is the cup. This is why the cup starts to sweat and condensation forms. This is also why your hands start to feel cold due to the absence of heat from the heat leaving your hand and going to the cup. So when heat flows into an object, the change in heat is positive. When heat flows out of an object, the change in heat is negative. So, how might energy be transferred? Thermal energy can be transferred in three ways. And this should be a review, as I mentioned previously, what we've been looking at for the past 2 years. We have conduction. Conduction is a transfer of energy through matter by direct contact of the particles. So, this is us directly touching something. Solids are the best conductors of heat, and this is because the particles are already so close together, so the contact is easy. The second way that we can transfer thermal energy is convection. Convection is a transfer of energy by the movement of heated particles. This only occurs in liquids and gases. And what happens is the currents move heat from warmer to cooler parts of the substance. And the third way that heat can be transferred or thermal energy is through radiation. And radiation is the transfer of energy through electromagnetic waves. This occurs fastest in gases and can be absorbed or reflected. They can travel through space and in between the molecules. So when you think about radiation, you can think about feeling the heat from the sun or putting your hands over a fire, not directly touching the flames, but just putting your hands over and feeling the heat radiate off of those flames. So some materials transfer heat well, whereas others do not. Conductors are materials that allow heat to flow easily. Examples include things like metals and your skin, whereas insulators are things that do not allow heat to flow easily. This is going to be things like air, wood, styrofoam, plastic, and fiberglass. So when you think about like your Owala cups or your Yeti cups or your Stanley cups, those are typically insulators because they will hold in heat and not allow that heat to transfer easily. So it can keep hot things warm and cool things cold. So as we wrap up with this lesson today, our target was to explain the transfer of heat. Today we're going to be looking at our heat transfer lab, and once you click that heat transfer lab, we're going to start looking at our potential energy and kinetic energy lab, which we'll go into more details about later this week. So at this point, if you have any questions, you can go ahead and put those in the chat, and I'll answer those through the chat. And next up, we're going to take a look at our lab and what is being asked of us with that lab this week, and then we'll get started.